Hi math class, amazing work this week working on your test review and on your test. You guys did such an awesome job showing all of your work. Myself and Miss Nielsen are really proud of all the hard work that you guys did, and we'll have all of your tests marked and returned by early next week. So for today's class, we're going to be looking at lesson 71, and we're going to focus on parts 1 through 5. So let's get started. I'll read what it says in our book for part 1. This is going to be a little bit new, so please follow along. So let's look at part 1. These are number families with whole numbers and fractions. You'll write the whole number as a fraction. Then you'll write the missing fraction. So let's look at family number 1 for part A. I'm going to quickly write it out. Right, so once again, if we look at these number families, they're different than the number families we've done before. Now we have fractions and whole numbers on them. So for part A, we have the number family that looks like this. Right, we have the fraction 1/7 as our little number. We're missing our other little number, and then for our big number, we have 3. So before we can do anything, our first step is going to be to change this 3 into a fraction. Right, so in order to do that, what I'm going to do is put it over 1. So remember, each fraction is over the whole number 1. So now what I want to do, in order to add or subtract fractions, I need them to have the same bottom number. Right, so these fractions do not have the same bottom number. So what I'm going to do is multiply this one by the other bottom number. So I'm going to multiply it by 7. So now, remember, whatever I do to my bottom number, I have to do to my top number. So if I multiplied the bottom number by 7, I'm going to multiply the top number by 7 as well. So now what I want to do is I'm going to just rewrite this as the new fraction. Right? So 3 multiplied by 7 gives me 21. And then 1 multiplied by 7 gives me 7. So now we changed the 3 that was here originally, we changed it into the fraction 21/7. Right, so I'll erase this so it doesn't get us confused. So once again, guys, how I got this fraction here is we changed the 3 and we put it over 1. Remember, each whole number is over 1. And then I multiplied the bottom number by 7 to have the same bottom number. And then to get the same, whatever I did to my bottom number, I had to do to my top number. And that's how I got this fraction. So now, both of my fractions have the same bottom number. I have to find out the new top number. Right, so it's going to be simple. I'm going to be subtracting. Right, so this is going to be my other little number. So the bottom number in my fraction will not change, so it will be over 7. The only thing that will change is my top number, right? So 21 subtract 1 will give me 20. Why did we subtract? Because we're looking for a little number. So our answer, guys, is going to be 20/7. So let's also try part B. We'll walk through the same steps, and then if you guys have any questions, please let myself or Miss Nielsen know, and we can we'll reach out and help you. In part B, once again, we have a whole number and a fraction. Let me write this out. Just like that. Right, so for part B, you have in your small number, you have the whole number 1. For your other small number, you have the fraction 7/15, and we're trying to find the big number. So once again, our first step is to change this whole number into a fraction. So my first step is going to be to put it over 1. Remember, each whole number is over 1. My next step now is to have both of the bottom numbers have the same bottom number. Right? This one's over 15, this one's over 1. So I'm going to multiply this one by 15. Whatever I do to the bottom number, I have to do to the top number. So I'm going to multiply the top number by 15 as well. So now I'm going to circle this and I'm going to change it into the new fraction. Right? So 1 multiplied by 15 gives me 15. And then 1 multiplied by 15 again gives me 15. So our new fraction is going to be 15 over 15. I'm going to erase this so we don't get confused. Right? But all we did is change the whole number 1 into a fraction that had the same bottom number as our other fraction. So now we have the two fractions, 15 over 15 and 7 over 15. Both of my fractions have the same bottom number, so now we have to find the big number. We remember that when we're adding or subtracting fractions, your bottom number will not change, so our bottom number will be the same. It will be 15. The only thing that will change is your top number. Since we're looking for a big number, we're going to have to add these two numbers up. Right, so we're going to add 15 and we're going to add 7. And that will give us the new top number in our fraction. So 15 plus 7 gives us 22. So our new fraction, or our big number, is 22 over 15. So we finished our number family for parts A and B. So what I want you guys to do now is, using the exact same steps that we used, try working on problems C and D. You can pause the video now, and then I'll see you guys in part 2. So welcome back to part 2. So in part 2, the title of this section is Multiplication as Division. So you're going to be given some multiplication problems, but they each have one missing number. In order to find out the missing number, you're going to have to change the multiplication problem into a division problem, solve, and then you'll get the missing number for your multiplication problem. Right, so for part A, we have the problem 3 multiplied by a number equals 624. Right, so we want to find out what will be the missing number for this multiplication problem. In order to do that, we have to change this into our division problem. The number that comes after the equal sign, this 624, will go underneath the division sign. So I'm going to write that right here. The number at the beginning, this 3, will go right before the division sign. So now that we've organized the problem into our division problem, we're going to start to divide. So I'm going to look at the 3 and look at the first number inside of the division problem. Can I multiply this or divide the 3 into the 6? Yes, I can. How many times can 3 go into 6? 3, 6, 2 times. So we're going to put the 2 right on top. Now I'm going to look at the next number, the 2. Can 3 divide into 2? No. So then I'm going to look at the next number as well. Can the 3 divide into 24? Yes, it can. How many times can it go into the 24? Right? 8 times. So I'm going to write the 8 just like that. But wait, remember guys, we can't do that. So I've noticed a lot of you guys were doing that when we had these types of problems, but we have to remember that we have to have the same number on top as we have on the bottom. Since the bottom number, or the number we're dividing into, has 3 digits, that means the number on the top will also have to have 3 digits. So therefore, I'm going to have to put a 0 and then my 8. Right, so now we've figured out the missing number, and now I can enter it into my division problem, into my multiplication problem. So 3 multiplied by 208 gives us 624. So what I want you guys to do is to use the exact same steps to solve for parts B and C. So once again, you're going to have to take your multiplication problem, change it into a division problem, solve, and then you can input that missing number into your multiplication problem. So you can pause the video now, and then I'll see you guys for part 3. So welcome back to part 3. For part 3, all we have to do is read through part 3 from the textbook. So I've attached an image in today's lesson. So if you can, please look at that. or just listen to what it says. So here's what it says in part 3 of our textbook. Here's an important rule about multiplication. If you multiply by more than 1, you end up with more than what you started out with. And if you multiply by less than 1, you end up with less than you start out with. So here's a problem. So the problem that they write for us is this. Right, so this is the problem that's in your textbook. So what it says is you can't see the number that 3 is multiplied by, right? So it's missing. However, you can figure out whether the number is more than 1 or less than 1. Just compare the number with what you start out with and the number you end up with. Right? So since the number we started out with is bigger than the number we ended up with, that means that this will be less than 1. However, right, in the next problem, or the next example, it gives us this problem. 3 multiplied by blank equals 4. We know that the number will be more than 1 because the number that we end up with is bigger than the number we started out with, right? So the 4 is bigger than the 3. That means the number I'm multiplying the 3 by will be more than 1. So that's all they want to show us, guys. That if the number you end up with is bigger than the number you started out with, that means you're multiplying by a number greater than 1. But if the number you end up with is smaller than the number you started out with, that means you're multiplying by less than 1. So let's look at number 4, or part 4. So for part 3, guys, we don't have any problems or any questions. We just had to review what it said in our textbook. So for part 4, we're doing number families. So it tells us in the instructions that you need to make a number family for each problem and answer the question. Don't forget to show all of your work, make sure to label all of your numbers, and to show all of your calculations. So let's look at part A. I'll read what it says. In a garden, there were red roses and 185 roses that were not red. There were 520 roses in all. How many red roses were there? Right, so if we look at that question, we can see that we're comparing two different things. And we also have one of our keywords that's highlighted or bolded, right? We have the keyword all. So all is going to be our big number. And then we're comparing two things. How many roses were red? And then how many roses were not red? I'll just put not. Right? So we have a few numbers that were given to us in the problem. It tells us that there were red roses, we don't know how many, and it also tells us that 185 roses were not red. Right? So I'm going to put the number 185 right above the not red. It also tells us how many roses were in all, 520. So what we have to figure out is how many roses were red. So I'm going to put a box here for our missing number, right? This is our small number. That means we're going to have to subtract, right? We're going to subtract 520 and 185. So make sure to show all of your calculations, right? So our first step, 0 minus 5, we can't do, so we have to borrow from the 2. The 2 will become a 1, and the 0 will become a 10. So 10 minus 5 gives us 5. Our next step is 1 minus 8. We can't solve, so I have to borrow from the 5, which becomes a 4, and then the 1 becomes an 11. 11 minus 8 gives us 3. And then our last step is 4 minus 1, which is 3. So our answer is 335. So 335 of the roses were red. So what I want you guys to do now is, using the same steps that we did, work on problem B for part 4. You can pause the video now, and then I'll see you in our last step, which is going to be part 5. So welcome back to part 5. In part 5, we're going to be looking for the area of a rectangle. So remember that the area of any rectangle is going to be, you're going to multiply the length by the width, or you're going to multiply one of the sides by the other side. So in problem A, we have the measurements 47 feet and 27 feet. All right, so we have to figure out what the area of this rectangle will be. Right, so we said that area equals the length multiplied by the width. Right, so our length in this case is going to be 43 feet. I'm going to multiply it by the width, which is 27 feet. I can't solve the way this problem is written, so I'm going to change it into a column problem. So right here, I'm going to write this question as a column problem. And we're going to multiply these two numbers. So my first step is to multiply the 7 and the 3. Right, so we can skip count by 7s 3 times, 7, 14, 21. So 21 will be our answer. I'm going to put my 1 down and carry the 2. Now I'm going to multiply the 7 and the 4, or you can skip count by 7s 4 times, right? 7, 14, 21, 28, and then we add the 2, which will give us 30. Now I'm going to use a different color to show our next step. So we multiplied the 7 with the two top numbers, so now I'm going to multiply this 2 with the top two numbers. I'll cross this 2 out that we carried over so we don't get it confused. Remember, this 2 is in the tens column. So to show that, I have to put a 0, right? And now I'm going to multiply the 2 and the 3, which gives us 6, and the 2 and the 4, which gives us 8. I'm almost done, but we have to remember our last step. Our last step will be to add all of these numbers up. So 1 plus 0 is 1, 6 plus 0 is 6, and then 8 plus 3 gives us 11. So our answer is 1,161. However, we're not done yet. Remember, when we're dealing with area, we need to have our units. So if you look at the units, we can tell that it's in feet. So our answer is going to be 1,161 square feet. So that's our area. Right, I have my units and I remember to have my square units. So for part B, we're going to follow the same steps. You're going to find the area of the rectangle that has the measurements 70 inches by 96 inches. Don't forget to add in your square inches. Make sure to show all of your work and all of your calculations. And if you guys have any questions, please let me know. Keep up the awesome work, and I hope you all have a great weekend. Bye.